we're going to look at finding solutions in an interval using a calculator. So first, we have to remember that inverse cosine is defined in quadrant 1 and quadrant 2, right, on the top. And inverse sine and inverse tangent are defined on the right-hand side, right? Quadrant 1 and quadrant 4. Didn't mean to do that. So what this means is the calculator will only give us one answer. Because if we're looking for a positive, it's only going to give us the quadrant 1 for cosine. It's not going to give us quadrant 1 and quadrant 4, right? So that means we're going to have to use our reference angles, our theta hats, to find the other solution. So what we're going to do is use the inverse tangent of y over x to find theta hat, and then use our reference angle rules, okay? Remember, this is inverse because we're finding an angle. That's where that -1 comes from, remember? And we really want to use the positive guy. We want to, because we want to find the quadrant 1 theta hat, right? We're not interested in a negative angle. So we want to be sure that my y and my x is positive, even if we're not in a positive quadrant, so that we can use our reference angle rules. Alex has really cool features on their calculator that is store and recall that'll help us here, and I'll explain that as we go through, okay? So first, just to kind of remember, when we're in quadrant 1, theta equals theta hat, right? They're the same thing, so then we're going to be good. In quadrant 2, remember this theta goes all the way around. So if I know what theta hat is, that reference angle, I can find theta by doing pi minus theta hat, right? In quadrant 3, again, this theta goes all the way around. I do pi plus theta hat to find theta. And in quadrant 4, we would do 2 pi minus theta hat. And you can always draw it out, sketch it out a little bit to see, be sure that it goes in the right spot. Okay, so let's see what we mean. It says find all solutions in the interval. Okay, so since we're in the interval, we know we're just looking at the unit circle, although these are not going to be unit circle values. So first, let's just think about tangent. This is tangent theta equals 2. Tangent is positive where the signs are the same, right? So I need quadrant 1 and quadrant 3. With me? So finding the quadrant 1 guy is the same as finding theta hat, right? And so theta hat is the inverse tangent of 2. So that means that theta is the inverse tangent of 2. That's my quadrant 1 guy, right? To find my quadrant 3 guy, I would use my reference angles, which tell me that theta is, we're in quadrant 3, so that's pi plus theta hat. And we said that theta hat is the inverse, is the inverse tangent of 2. So these are my two answers. When I talked about store and recall, what you can do is in Alex, when you type in the inverse tangent of 2 and hit enter, you click store, and you'll see it in Alex on that calculator. So once you store that answer, when you need it again for pi plus, you just do pi plus recall, and it'll pull that answer back up, okay? That way you don't have to type all that in again. So those would be your two answers right there when you put them in the calculator. Now this does say from 0 to 2 pi, so we want to be sure that we're in radians. Okay, so let's talk about the sine of theta being 3/4. So if the sine is positive, that means that we are on the top, right? We're in quadrant 1 and quadrant 2. So if I were to just do the inverse sine of 3/4, it's going to give me quadrant 1, right? So we know that in quadrant 1, let me specify that here. In quadrant 1, we know that theta equals theta hat, right? So theta is the inverse sine, of 3/4. So that's my first answer. Then we've got to talk about quadrant 2. In quadrant 2, theta is pi minus theta hat. Which is pi minus the inverse sine of 3/4. So again, this is my second answer, and I would just store this when I got it. And then for the second one, I would use the recall button to get this value back. Are you okay? All right, so on this one, I'm doing secant theta is -7/4. So let's talk about that for a second. Secant is negative where cosine is negative, correct? And cosine is negative on the left-hand side, which is quadrant 2 and quadrant 3. Now, this is the first time that we've had one where we weren't looking for the quadrant 1 guy, okay? But we want to go ahead and find the quadrant 1 guy because theta hat is in quadrant 1, correct? So if I find theta hat, then I can use my rules to get quadrant 2 and quadrant 3. Now, if I were to flip that and in my calculator do inverse cosine of -4/7, right? My calculator would give me an answer, but it would give me quadrant 2. And then it's difficult from there to find quadrant 3, okay? Because then we have to find the reference angle anyway. So we're just going to start by finding theta hat. And so theta hat, we're going to say, is the inverse cosine of 4/7. Right, we would do the inverse secant of 7/4, but we don't have an inverse secant button, so we just flip it over, right? So we're going to do the inverse cosine of 4/7. And the reason I'm using the positive is so I can get the reference angle, okay, that quadrant 1 positive guy, because if I use the negative, it's going to give me the guy in quadrant 2, and then we're going to have to do the math to find quadrant 3, right? This is much simpler. So then if I want the quadrant 2 guy, in quadrant 2, theta is pi minus theta hat. So that's theta is pi minus the inverse cosine of 4 over 7. And we would store that, or we would store the inverse cosine of 4 over 7, right? And in quadrant 3, theta is pi plus theta hat, which is pi plus the inverse cosine of 4 over 7. So I would use the calculator to find the inverse cosine of 4 over 7 and store this here. And then do pi minus the recall, right? And pi plus the recall. It just makes it much simpler. And you could tell pretty well, let me see, let me do this real quick. Let me make sure I'm in the right mode. Mode. I am not. There we go. So if I do the inverse cosine of 4 over 7, I get 0.96. Okay? So let me store that. Yep. Maybe. There we go. This is not working. On my calculator, it's different, this one I'm using, than what you would do on Alex. So pi minus the inverse cosine of 4 over 7 gives me 2.17, which I feel like that's in quadrant 2, right? Because pi is 3.14, so that feels like quadrant 2 to me. And then if I do pi plus, I get 4.1, so that feels like quadrant 3. All right, last one of these. The cosecant of 4/3. So first, let's think about which quadrants we're in. Sign is positive on the top, right? So that's quadrant 1 and quadrant 2. So my quadrant 1 guy is where theta equals theta hat, right? And so theta and theta hat are both the inverse sine of 3/4. That's our quadrant 1 guy. And then our quadrant 2 guy, in quadrant 2, theta is pi minus theta hat, which is the same as that theta we found. So pi minus the inverse sine of 3/4. And that would be your second guy. So always find your theta hat first. Once you find your theta hat, then use those rules, your reference angles.